Assistant Professor, Department of EEE, SNS College of Technology. In this lecture series video of electric circuit analysis, today's topic is about superposition theorem. So we are going to solve the problem number 3. So previously we have solved a number of problems based on superposition theorem, which has two sources and two different sources. In this circuit, we are having three sources. So already we know that in superposition theorem, source is the representative of your steps. So here we are having 8 amps current source, 100 volt voltage source and 60 volt voltage source, three sources. So we are going to derive the whole problem by using the three steps. By keeping one source active and other remaining sources deactivated state. So in this step 1, 8 amp source is active source, which means current source is active source and remaining sources are deactivated sources. So we already know that if it is a voltage source, we have to short circuit the voltage. So by short circuiting this 100 volt and 60 volt, we are having a resistor connected in parallel with this 100 volt resistor. So we know that in superposition theorem, if any source across the voltage is connected in parallel, we have to neglect this resistance value. So this short circuit is connected in parallel with this resistance value. So we have neglected the 60 volt. So rewrite the diagram as 8 volt and this resistance value as a neglected source. Here we have that 50 ohms, 30 ohms and 8 ohms, 8 amps resistor, where here the source is short circuited. So 8 amps and 50 ohms are in parallel. So current source and voltage resistance source is in parallel. So we are applying the current division rule. So we know that in current division rule we have to apply the formula of current opposite current into opposite resistor divided by sum of the resistor. So this is the current division rule formula. So by applying this, we have to find out the I dash value. So applying this value, we can get 5 amps as the I dash. So keeping the other two sources inactive, the 60 volt source is an active source. We are keeping the step 100 volt source as an active source and remaining source as a deactivated source. So here we can define that these sources connected in parallel. So that applying the parallel formula R1 into R2 divided by R1 plus R2, we can get the value of 20 ohms. So we rewrite these voltage resistance value as 20 ohms in this circuit. So here these two is connected in series. So we have to apply the series formula R1 plus R2. We can get the value of 50 plus 30 equal to 80 ohms. So again we redraw the diagram. It shows that 80 and 20 ohms is connected in parallel. So again we are rewriting this parallel formula 80 into 20 divided by 80 plus 20. We can get 16 volt. So draw the equivalent circuit for these sources. We are having a 100 volt resistor and a 16 ohms resistance source. So applying this Ohm's law, I is equal to V by R, we can get the value of 6.2 amps as a current I double dash. So we can solve the two steps. The remaining one step has to be solved. So step 3, 60 volt source is an active source. By keeping the 60 volt source as an active source, remaining circuits are open circuited and short circuited. We already know that the short circuited value is neglected. Hence, this neglected value, we can have these loop only. So 30 ohms and 60 volt resistor. The current across this loop is known as I double dash, I triple dash. So reapplying the Ohm's law value I is equal to V by R, we can get I triple dash that's equal to voltage source 60, resistance source 30. So 60 by 30 is equal to I double dash equal to 2 amps. So we can get the three values by activating and deactivating the source. From the first step, we can get the I equal to 5 amps. From the second step, we can get I equal to 6.25 amps. From the third step, we can get I equal to 2 amps. So we are now having three values of current. But in the question, we are applying the superposition principle to find the value of I. But now, as of now, we have solved I dash, I double dash and I triple dash. So solving all those things, we can get the I value. So I is equal to minus I dash plus I double dash minus I triple dash by applying the KCL value. So incoming current is equal to outgoing current. We can get the value of I is equal to minus 0.0 So this is your final